So there we have an equation, and they just tell us it's y equals f of x. They don't give us an explicit equation. An explicit equation is one that has the only x. They just give us a function notation for this equation, and they want us to sketch the graph of y equals negative 1/4 f of x. So what you're going to be looking for is what's different. Well, we've got the negative and the 1/4. Is that inside or outside of the function? It's outside. So all of that is going to affect the y values. If I were to describe this, I'd have to describe two things. The negative would be one thing that I would describe, and the 1/4 would be another thing that I would describe. If I was describing the negative, I would say that that is a flip over the something axis. Which one, x or y? X, y, y. Yes. So what you have to do again is think that negative is outside. If a y value becomes negative, so I take a point up here, and that y value becomes negative, it would go down here. And since it would move up and down vertically, that's going to flip over the x-axis. And the 1/4, that means you're going to multiply your y values by 1/4. If we look what a flip over the x-axis does, that multiplies your y values by a negative 1. And what we're going to find is when we're doing reflections and stretches, or reflections and compressions, we use the word stretch when things get bigger. We use the word compression when things get squished. When we're doing both of those, we can do them together. Because if I'm multiplying y by negative 1 and I'm multiplying y by 1/4, I can do those both at the same time by multiplying y by negative 1/4. Moving things left and right, up and down, was easy just to count and do it. With multiplying the y values, we're going to use the strategy that we sort of started this morning. We're going to take key points on our original graph. And for this graph, that's probably the most important point, 0, 0. But we're going to take a couple other points as well. Now, choosing your points, you can choose any points, but some points are nicer than others. For example, I would not choose any really decimal-y numbers. I don't think that would be very easy to do the math with. I'm going to probably pick whole numbers. So most people choose the first one that they run into. Maybe they would say, oh, that's the first whole number. That is at 2, 2. But I want you to also think about what's going to happen to this point. You see that your y value is going to be multiplied by negative 1/4, which is like dividing by 4. So if I want to avoid fractions, if I chose this point, it's going to be nicer because I can divide that y value of 4 by 4 easily and I'll get a whole number. Or you might even want to choose this point. That would be a nice number too because 8 divides nicely by 4. So when choosing some points, I'll start with this one here. I'm going to see what happens to 4, 4. And just so that I have something on this side, I could do this symmetrical one, but just for fun, I'm going to pick negative 8, 8. So you can choose any couple of points on your original line. And then after you've chosen some points on your original line, we're going to draw that arrow just like we drew this morning to show that we're changing that. And above this arrow, we're going to write what we're going to do to change it. And we're going to change it by multiplying our y values by negative 1/4. So what is that going to do to 0, 0? If you multiply the y coordinate by negative 1/4, it's going to stay 0, 0. We're only multiplying the y's, so in both of these points, you would already know that the x values don't change. But if the y value was 4 and you multiplied by negative 1/4, it will now be negative 1. If the y value, oh, it didn't change. Here we go. There we go. If the y value was 8, and you multiplied by a -1/4, it would become -2. Once you've done that, we can now plot those 3 points. We still have 0, 0. We now have 4, -1. Careful here that you don't go down the full step because this graph is going by 2's. And -8, -2, that would be right there. Draw your new graph. And what's a little bit different from translating is when you translate a graph left, right, up, down, it's exactly the same shape that you started with. When you squish things, the shape changes a little bit. The basic idea of the shape is still there, but if we think about the words that we wrote to begin with, has it been flipped over the x-axis? Yes. Have the y values been multiplied by 1/4? We would call this a vertical compression. And the way that you think of vertical stretches and vertical compressions is as follows. Take your x-axis. If you have a vertical compression, imagine some sort of like trash chomper above and below pushing down towards the x-axis. It'll squish it both ways. In this case, the red graph was all above the x-axis. So if you imagine a bar at the x-axis and squishing down, it would have gotten flatter. Plus the reflection over gives us the result that we have. Whenever you're multiplying y by a number bigger than 1, we're going to call that a vertical stretch. And we imagine grabbing the graph above and below the x-axis and pulling it away. And that will stretch it out further. Questions you can do for this one are just question number 3. We are going to do the next example because it's just one example, so you have a couple to work on. I also want you to notice in this question that you recognize this is one of our parent graphs. This red one, if you had a name for it, the explicit equation would be y equals the absolute value of x. And so this blue graph, its equation would be y equals the -1/4 would be out in front of that absolute value of x. And so that would be the actual equation of this one if we wanted to write that. We are going to move on to question 2, so we're going to skip this thing that they have there. A little bit of an explanation here of what happens, but again, we're going to see this happening by the fact that what's outside the function is going to multiply your y values exactly as you see that number, and what is inside the function is going to multiply the x values, but not how you see it. We saw it this morning with the reciprocal. So again, things inside the function don't happen exactly as you see them, but things outside of the function do.